Hello everyone, my name is Seungwon. I'm studying as a master at Jungwon University in Seoul, Korea. Today, I'd like to introduce blockchain-based concept model for construction quality management, which is ongoing project on my lab, Construction Technology Innovation Lab, and would like to share and discuss its potentials, difficulties, and challenges with you. This presentation consists of four portions: research background and introduction, process of blockchain-based quality management system, use case scenario, and last, use of research results and expected effect. So this is the research background. Recently, in Korea, large and small accidents have occurred due to poor construction practices, and quality is being discussed as a major issue. Defects in construction of buildings lead to repairs and rework, resulting in lower profitability. Accidents caused due to collapse of buildings because of foundation movement, defects of construction apartments, and delays in repair and treatment of defects causes serious adverse effects as well as social problems such as psychological damage to tenants due to awareness of the risks. In particular, the cost incurred by defect treatment and rework due to poor construction is at a serious level of 3 to 9% of the construction cost. Examples include the collapse of the Pyeongtaek International Bridge, the Sangdo Kindergarten ground subsidence, the damage to the pillar due to the Pohang earthquake, and dropping of the outer wall of the Busan National University Museum. Since quality is directly connected to safety of both the user as well as the building itself, which can be improved through quality control and management in the construction process. In addition, the number of reported disputes due to the defects in apartments, the most common issue occurring in housing in Korea, has increased 56 times from 69 cases in 2010 to 3880 in 2016. This highlights the quality management and control issue in the Korea construction industry. Currently, various systems are in operation in Korean construction industry to manage and supervise construction quality. Inherent limitations of post-construction inspection and evaluation, human-oriented manual inspection confirmation, document-based evaluation process, and quality information. Human-oriented manual inspection has limitation both in terms of the process of inspection as well as the administration power of government agencies for regulation on numerous construction sites. In addition, even when quality management experts were deployed on sites, research results show that 67% of them missed the inspection test due to excessive workload or there was a reported shortage of manpower. All work steps at each site need to check in order to achieve the necessary requirement. Practically, it is impossible to do so, and there is a high possibility that post-inspection will be performed after accident occurs. In addition, document-based quality evaluation record has limitations in securing reliable information. For this reason, it is necessary to generate construction information related to quality in inspection staging. It is necessary to generate construction information related to the quality inspection in specific stage of work when the worker is performing the actual work. There is a need for a systemic approach that can automatically determine the generated information by a system beside human and secure the reliability of the generated information. Therefore, in this study, we intend to develop an innovative quality management system framework that utilizes blockchain technology, which has recently attracted much interest in the construction field. Then try to convert the paradigm that construction information relates to the quality of major unit work that affects The quality can be generated at the level of the worker performing the actual work. So blockchain technology is being used in various industries to manage information securely and enhance reliability based on the distributed ledger technology, which is called DLT. Examples of application include energy transaction, voting, and medical care. Smart contract is considered as the most effective blockchain technology in the construction field, and if it can secure transparency and complementarity of transaction in subcontracting, supply chain, and supply of materials and real estate transaction. The problem of persistent distrust in the construction industry can mostly be solved by the smart contract technology. However, there's a little research in this field related to the quality, which is the subject of this study. It can be roughly divided into a group that contain quality management related activity of a construction project and a group that verify it. Quality activity information generated at the site is mainly generated by construction companies and partners, and the generated information is stored in the quality management activity database. Verification of the conformity of the stored information is evaluated in the system based evaluating the system based on the rule or algorithm according to the distributed ledger target. In the process of creating quality control information and reading the ledger by using the Hyperledger consensus algorithm to check the author's or viewer's authority to ensure the reliability of the stored data and prevent unauthorized user from accessing the ledger. Blockchain network data overload can be prevented by storing large amount of data like a photo or BIM data or that kind of big data in a single database outside of the blockchain and recording the hash and URL of the data in the distributed ledger. Through the Hyperledger channel separation and MSB function, the contractor can view the ledger of the supplier channel 2, but supplier composes a data hierarchy that cannot be read by the contractor channel 1. In addition, by granting the authority to participate in channel 1 and channel 2 to inspection agencies, orders, and supervisor, the quality level evaluation information of construction companies and partners recorded in the blockchain can be viewed. The following scenarios are selected from the major poor quality cases selected by government ministries. As a solution, I will briefly explain the application of this system and which verification technologies are applied in the process. As the applied verification technology, the generated information would be used by a non-human system to automatically determine compliance with quality-related regulation and procedures. As the reliability of the quality management, the conformance result would be stored in the blockchain. So, for instance, inspecting the struts when installing the shoring and shielding system in an excavate site, the manager takes image of each job step during work progress. The augmented reality, which is called AR-based image matching techniques, check the installation status and accuracy of the strut. Any discrepancy could be recorded and sent to the database. The blockchain system could generate a hash for each generated record and will save on the server. The following is a solution to the quality management problem related to the side cushioning installation. Using image recognition technology, if a quality manager or operator takes a picture after installing the side cushioning material, the system checks the location and time to determine the installation. The determined result value would be stored in the blockchain. And in order to solve the quality management problem related to the concrete backfilling compliance, picture would be uploaded after concrete pouring and before backfilling. By comparing and analyzing the time log of the uploaded photo, can figure out if 7 days have elapsed after concrete was poured and backfilling work was performed. The time log and corresponding picture would be saved in the blockchain. And in waterproofing work, there are various layers of different materials to be painted and finished on the surface with specific time intervals. The manager captures the images after finishing the primary layer and before starting the second layer. The rule-based engine analyzes the image with corresponding time reference and record the hash against each transaction in the blockchain. And calculating compressive strength of concrete is very critical in construction of structural works. Initially, the quality inspector in the lab takes image of concrete mold during curing underwater. Then the inspector captures the compressive strength results after 3, 7, and 28 days by doing experiments on universal testing machine, which is called UTM. The system can then generate the hash against both the image and will be saved in the blockchain. Other data, such as image or document, will be stored in the external database. In order to have reliable quality and fitness to use information, the document certificate made against each particular inspection. Inspection for concerned equipment or materials could be uploaded to the blockchain system. The images of the document can be converted to the text using optical character recognition technology, which is called OCR, or text mining. Then the required important information such as data, time, location, and fitness can be extracted, and their corresponding hash along with URL could be stored in the blockchain. In this page, I'd like to discuss about the contribution of this research for the aspect of the technology to define core management content for quality assurance in the construction process and applying various fourth industrial technology like AR, IoT, image recognition, and timestamp that can be identified. In addition, it intends to contribute to academic progress by implementing blockchain core technologies, which secure reliability and prevent fabrication for construction quality management and showing example of use case. For the aspect of improve current quality management method, the paradigm of the existing quality management work, such as inspection by manpower, will change to remote inspection and reducing administrative work with automatic conformance checking and reliable quality management information. In addition, it could be changed from the top-down to bottom-up quality management by generating quality data from worker. For the aspect of quality performance level, the level measured by suggested system can be contributed to the further field and can be utilized like a reputation of worker or company, insurance rate related to construction quality, incentive for quality performance, and bidding advantage about quality performance level. Thank you for listening my presentation.